Hey everyone, welcome back. This is Arthur Morris, and in this video we're going to look at simplifying a product of radical expressions, multivariate. So we have more than one variable in this one, but the process is still the same. So we have the square root of 6 times x to the 8th times w to the 5th times the square root of 3 times x times w to the 8th. So let's get this all moved and combined and together under one radical. So I'm going to go ahead and break down that 6 to 2 times 3, and then that 3 from the other radical. Then I have x to the 8th times x to the 1st. Then I have w to the 5th times w to the 8th. Now, this one, everything is the same except for those w's, because since I have w to the 5th, which is higher than w to the 1st power, and w to the 8th, then I think it's probably a good idea that I combine those and re-break them down. So let's go over out to the side and say w to the 5th times w to the 8th. When we multiply like basis, we add the exponents. So that's w to the 13th. So what we want underneath there, we want the next number down that would be an even exponent, so we can take the square root of it. So I want to rewrite this w to the 13th as w times w to the 12th. So let's rewrite this thing here. So it's still the same thing, just written in a different form, which allows me to take the square root of that and fully simplify it. So simplify the 3 times 3, the x to the 8th, and the w to the 12th. Okay, so 3 times 3, that means I can bring a 3 outside of the radical. X to the 8th, 8 divided by 2, the root of 2 is x to the 4th. W to the 12th, 12 divided by 2 is 6, so w to the 6th. And then left underneath my radical, I have 2xw. Again, the reason I did this and I didn't do the x to the 8th and x to the 1st is because this is x to the 1st, so that would only be adding 1 to that 8. If I did, I would just be working backwards pretty much, or doubling my work. So if I had x to the 8th and x to the 1st and I combine those, that's x to the 9th, but I still want an even exponent, so I can take the square root, so I would have to break it back down as x to the 1st times x to the 8th, which is the same thing. All right, so this one, we have the square root of 8 times w times v squared times the square root of 2 times w to the 7th times v. Okay, so let's look at this. If I break 8 down, it's 2 times 2 times 2. I have that other 2 there. W to the 1st, w to the 7th. Leave those like they are, and then v to the 1st and v to the 2nd. So I just took everything and put it underneath one radical. Now it's no need for me to combine any, well, I'll take that back. I was about to say it's no need to combine the variables, but looking here at the w's, this w has, both of these w's have odd exponents. So if I combine those, w to the 1st and w to the 7th, that gives me w to the 8th, which will then allow me to simplify and take the square root of that. So let's rewrite this thing out. Combining those w's to make w to the 8th, because I want that even exponent so I can divide by that root, that even root. All right, so let's see what we have. We have a pair of 2's. Whoa, sorry, went up on you fast. We have a pair of 2's another pair of 2's, a w to the 8th, and a v square. All of those can be simplified, or taking this, we can take the square root of each one of those. So it gives me 2 from this pair of 2's times 2 from that pair of 2's times w to the 4th times v to the first power, and then I had a v left underneath my radical. So simplify on the outside there. And there you go. Okay, so that's it for this objective. I hope you found it to be helpful. Thank you.